right, everybody, example number 11 is talking about some geometry. So we're trying to find the volume of the largest cone that can be inscribed inside a sphere of radius 5. So I kind of did the best I could. I definitely did the best that I could. It kind of looks like a circle and a cone inside. So, all right, so don't worry about not being perfect or anything. So that's like my cone, right? Inside the sphere. Now, the only thing that we know for sure is that the radius of the sphere is 5. So I don't know if that's going to be from here over. This is the radius of the cone. The radius of the sphere has to come from the center of the sphere. So let's say the center of the sphere is right here. And so a radius could be drawn right here. Like you could draw this as R. You could also draw a radius to each corner of the cone. Okay? So I don't know if this is going to be like a short and fat cone or if it's going to be tall and skinny. So the base of the cone could be like below the center of the sphere, or it could be above the center of the sphere. So I can't put the radius of the cone equal to the radius of the sphere because we don't know for sure where that base of the cone is going to end up. But I can do the diagonal ones because each corner of the cone is on the edge of the sphere. And so we know for sure that from the center out to a vertex of the cone, that's going to be equal to the radius, which is 5. So actually, I'm going to put a little 5 in here. Okay, like that. All right, now we're trying to find the volume of the largest cone. So the volume of the largest cone. We are trying to maximize volume of a cone. So we're going to be taking the derivative of the volume formula of a cone. So the volume formula of a cone is 1/3 pi r squared h. We're going to take the derivative of that. Now, our only problem is that it's in 2 variables. So we want to get it into 1 variable. So we better look at what else we have going on here. Doesn't look like they give us a whole lot of information, do they? We're definitely going to use this 5 somehow. Let's think about this here. So when I'm talking about this formula right here for the volume of a cone, the radius that I'm talking about is not 5, okay? The radius that I'm talking about, which maybe if I use a different color, it'll look a little better. I'll go with this and see if this green stands out. I don't know. The radius is actually the radius of the cone. So this is the radius that we would use to find the volume of the cone, okay? This R. I don't know what that R is. I'm just gonna call it R. The height that we would use would be the height of the cone, which actually is all of this, okay? All of this is the height of the cone, all right? So I know part of it is 5, and then the other part of it is like this little tiny piece right here. Well, this little tiny piece right here, you could call this like, I don't know, let's see here. Let's just call this, we'll call this big H for the height of the cone. And we'll call this like little h right there. Okay? So this little tiny height right here, when you add it to 5, gives you big H. Okay, so we know that big H is going to be equal to 5 plus little h. Hopefully that's not like too confusing with like too many H's and stuff, but all right, hopefully you're all right. Okay, so The other thing that we know for sure is that the height of the cone has to be perpendicular to the radius of the cone. That's the only way to like get the height correct, right? It's like has to be perpendicular to the base. Otherwise we'd be measuring the height like on a slant, and that wouldn't truly be a height. So that's going to be 90 degrees. Okay, so here's the deal with this. There's another little shape inside of this diagram that's going to be our helper, and it's going to help us come up with an equation that will get this volume formula in terms of one variable. And so maybe you see it, but it is right here. That little tiny right triangle down there, that's what we're going to use, okay? We can use Pythagorean theorem with that. All right, so Pythagorean theorem says that this would be, where can I put this where I'm not going to like take up too much space? It would be h squared plus r squared equals 5 squared, okay? H squared plus r squared equals 5 squared. All right, so I have r squared right here in my volume formula. So I could solve this for r squared. 5 squared is just 25. Okay. And take this, like don't worry about taking the square root. It's not worth it because you have an r squared right here. So just keep it r squared and take all of this 25 minus h squared and put it in for the r squared. And then you'll be all taken care of with that. So take this and plug it in right here. So volume equals 1/3 pi 25 minus h squared times big H. All right, now we're pretty close. At least we have the letter H, but unfortunately we have little h and we have big H. Little a, we can't have like two different kinds of H's. Gotta have the same kind. So we're gonna use this down here. We know that big H is equal to 5 plus little h. So take that and plug it in for your big H. So V equals 1/3 pi 25 minus h squared times 5 plus h. Okay. Now we have a volume formula that is all in terms of one variable, which is awesome. And now we just have to take the derivative and set it equal to 0 and find reasonable solutions. So let's see what we can do here. So we're going to take the derivative dv dh. And so 1/3 and pi are just constants. So I'm just going to pull them out like this and not use them, like not do anything with them. And I'm going to use that product rule again. So this is u and this is v. So u prime would be negative 2h times v plus v prime is just 1 times u, 25 minus h squared, like that. Okay. All right, now I'm going to clean things up a little bit. Give myself a little bit more space. Let's see, this will be negative 10h minus 2h squared plus 25 minus h squared, like that. And we could continue to combine. And I'm going to write it in descending order. So negative 2h squared and negative h squared are going to combine to negative 3h squared. minus 10h plus 25. Okay. So that's our derivative. We're going to set that equal to 0 because we are trying to maximize the volume. So we're looking for a maximum. The 1/3 and the pi, if you divide those on both sides or multiply by the reciprocal, however you want to do it, they're going to just go away because you're going to do 0 divided by that. So it's going to go away. This is what we need to find the factors for. So it would be what multiplies to negative 75 and adds up to negative 10. Multiplies to negative 75 and adds up to negative 10. I think that's going to be negative 15 and 5. Yep. So I'm going to come over here, see if I can squeeze this in. So negative 3h squared minus 15h plus 5h plus 25. And then remember, this is set equal to 0. You've got 4 terms, so we will group, take out the negative, 3h. This will be h plus 5 plus 5, h plus 5, like that. So negative 3h plus 5 equals 0, and h plus 5 equals 0. So little h is either going to be negative 5, or it's going to be, subtract 5 to 5, so it's going to be 5/3. Okay, now real life problem, like if we were actually trying to build this, okay, or create this, can't have negative height, so that goes out, and we're left with h equals 5/3. Okay. So you were asked to find the volume, like actually figure out what the volume would be of the largest cone. So that's where, I guess I'm going to go over here. That's my only little free spot. That's where we go back to the original volume formula. And we fill in very carefully with what we know. So the volume is going to be 1/3 pi. Big R is right, well, this is r squared, so we'll have to take the square root of this. Big R would be the square root of 25 minus h squared. Little h squared, that is. So we have to put the 5/3 that we just got from little h in right here. I'm going to allow Desmos to help me out with this. So what did we say? So square root of 25 minus 5/3 squared. And that looks like that is, I'm going to go to 4 decimal places on this, okay? So that way our final answer will be to 3 decimal places. So big R, oh, actually, we didn't have to take the square root of that, did we? I didn't even think about that. We had r squared, so we could have gone right back up here, couldn't we? All right, hold on here. Let's just get rid of this. So I just need to know what 25 minus 5/3 is. Probably a lot of you were thinking that, like, why isn't she just doing the underneath part? Okay, so 23 1/3. Oh, that had to be squared, didn't it? 5/3 squared. 22.2 repeating. So this is 22.2222. I'll do 4 of them repeating. Okay. Times big H. Big H is right here. So you have to add 5 plus little h to get to big H. So that would be 5 plus 5/3. Oops. Like that. which is 6.6 repeating. 1, 2, 3, 4. So we have that. So 1/3 times pi times 22.1234 times 6.1234. Looks like we get roughly, to 3 decimal places, 155.139. And this would be units cubed, since it is volume. All right. There you have it.